functions, first thing we're going to do is write down a few functions so that we'll have something to work with. F of x is equal to 2x minus 1. Our g of x will be 1 plus x squared. We're going to let our h of x equal the square root of 3 minus x. And our k of x we're going to make into a piecewise function. So he is equal to x squared minus 4 over x minus 2 if our x is not equal to 2. If it's equal to 2, we're going to let our k of x equal 8. And we'll come back and talk about that when we actually plug into that function. So there are the 4 functions that we're going to be using on this video. So we'll refer back to that as we can. Here's the first one we want you to find. Let's find f of 2. If we're asked to find f of 2, remember a couple of things that we mentioned in class. When they ask you to evaluate a function, the name of the function tells me which function to plug into. The number inside the parentheses tells me what to plug in. Once I understand those two things, I'm ready to solve any of these. F of 2 means I'm going to be plugging into function f above. Function f looked like 2x minus 1. A neat trick is to go ahead and write the function but replace all of your variables or x's with a parentheses. So we have 2 times x minus 1 that we're plugging into. Now everywhere they had an x, you're going to replace it with 2. So 2 times 2 minus 1, that's 4 minus 1. This function's value is 3. Let's evaluate g of 3. To evaluate g of 3, again, you go up to the original functions and you see that it's equal to 1 plus x squared. So I'll write it with the x's replaced with parentheses. So I have 1 plus x squared. Now everywhere they had an x, I'll replace it with 3. I have 1 plus 3 squared, which is 9. So my function's value is 10. Let's evaluate function h at negative 2. If we're evaluating function h at negative 2, we look above and we notice that function h was the square root of 3 minus x. Notice, again, I'm replacing the x's in the original function with parentheses so that now I can come back and evaluate it at negative 2. This cleans up to become the square root of 3 minus the minus 2, which is plus 2, or the square root of 5. We want to take a peek at our piecewise function as well. So let's start off by evaluating it k at negative 3. Now k was a piecewise function, so you have to qualify your x. Where is x in negative 3 going to fall? If I look back up here at my piecewise function, if my x is equal to negative 3, it's not equal to 2 or it's equal to 2. I think it fits in the not equal to 2 category. So this is the piece of the function that we're going to use to evaluate it. So we come back on down here. We're going to use x squared minus 4 over x minus 2 to evaluate our function. So everywhere they have an x, we're going to put in a negative 3. So we have negative 3 squared is 9 minus 4, that's 5. Negative 3 minus 2, that's negative 5. So my value, or the value of k at negative 3, is equal to negative 1. Just real quick because we have it, k of 2. If we're evaluating function k at 2, remember from our piecewise function up here, it says if our x is equal to 2, then the value of the entire function is 8. So down here where we're asked to evaluate k of 2, we simply write down 8. One last type of function that I want you to take a peek at, or problem, is a composite function. Let's just take a peek at this one, f of g of negative 1. If we're asked to evaluate f of g of negative 1, first thing we have to do is translate the function. That function can be translated into f of g of negative 1. The translation makes it a lot easier to see what you're having to do. Now start working from the inside of the function out. So first thing we're going to do is evaluate g at negative 1. So we have f of g at negative 1. Don't forget, function g is 1 plus x squared. Everywhere we had an x in function g, we're replacing it with negative 1. So we're going to clean that up. That's 1 plus negative 1 squared, which is 1, so that gives me a value of 2. We've cleaned up g of negative 1. It gave us a value of 2. Now we're going to step outside and evaluate function f at 2 to finish up this problem. Function f was 2x minus 1 above. I replaced my x's with parentheses, and now we're going to replace those x's with 2. So my final value is 4 minus 1, or 3. The function of the composite function f of g evaluated at negative 1 is equal to 3.